lesson 26, the definition of sine, cosine, and tangent. I told you the last couple of lessons that we were working on getting to the introduction of these terms. So we're going to look at just the first couple of examples here. It says identify the opposite over hypotenuse ratios for angles A and angles B. Alright, so let's do our angle A first. Remember the angle, or the side opposite of angle A would be 12. And the hypotenuse of my triangle is 13. Alright. For angle B, the side opposite of angle B is 5. And remember, my hypotenuse does not change. So these are the ratios for angle A, and these are the ratios for angle B. Identify the adjacent over hypotenuse ratios for angle A and angle B. Alright, angle A. If you remember, the adjacent side is the side that helps make that angle. So it's the leg that helps make the angle, so that would be 5. Once again, my hypotenuse does not change. It's 13. Alright, and for angle B, the side that is the adjacent would be 12 over 13. Describe the relationship between the ratios for angles A and angle B. Alright, so if you notice, the opposite over hypotenuse for angle A is the same as the adjacent over the hypotenuse for angle B. So we'll say the opposite over hypotenuse for angle A is the same as the adjacent over hypotenuse for angle B, and vice versa. The opposite over hypotenuse for angle B is the same as the adjacent over hypotenuse for angle A. Alright? So that's the relationship that we see here. Alright, so I told you that we are going to get into what we call sine, cosine, and tangent. Alright, so let's kind of do a little bit of a discussion before we get into the actual lesson. I'm going to talk to you about how to find the sine, cosine, and tangent of angles. Alright, so in everyday life, we reference objects and people by name, especially when we use the objects and see the person frequently. Imagine always calling your friend hey, or him, or her, or friend. We want to be able to easily distinguish and identify a person, so we use a name. The same reasoning can be applied to the fractional expressions that we have been investigating, our opposite over hypotenuse, our adjacent over our hypotenuse, and the opposite over adjacent. So, in other words, we want to come up with a familiar name instead of having to say the opposite over the hypotenuse or the adjacent over the hypotenuse. We want to come up with a familiar name for that. And that's where our vocabulary comes in today. Alright, so normally we would say that these are ratios. But we want to avoid saying the value of that ratio, or opposite to hypotenuse, or opposite over hypotenuse. Alright? So we want to call these fractional expressions, or in other words, our trigonometric ratios. Alright? So these ratios were discovered long ago and have several names. The names we currently use are translations of Latin words. And so we're going to learn more about the history behind this in Algebra 2. We're not going to deal with a whole lot of the history here. All right, so presently, mathematicians have agreed upon the names of sine, cosine, and tangent. All right, so let's look at this. All right, so these are the three words that we use to describe the opposite over hypotenuse, the adjacent over hypotenuse, the opposite over adjacent. All right? So we're going to now get into being able to call them sine, cosine, and tangent. All right, so here's another thing I want to introduce to you. We want to make sure that we look at this. I want to show you this. All right? And what you're going to see printed is more of an oval, but that's okay. So this is talking about a measure angle. All right? So that is a measure angle. All right, so let's kind of look at a triangle for a moment. So let me draw a triangle here. All right, so we've got triangle A, B, C. This is our hypotenuse. In reference to angle A, remember we mark it this way. In reference to angle A, this would be the opposite, and this would be the adjacent. All right, so for the lesson purpose, we are going to be in reference to angle A. All right? So we're going to use this to represent the angle measure of angle A. All right? So let's talk about sine. So if I want to find the sine of my angle, in other words, the sine of angle A, we would write it this way, or we could write it the sine of A, all right? So here's how I find sine. Sine is the opposite over the hypotenuse. All right? Sine is the opposite over hypotenuse. So in reference to angle A, then I would say the sine of angle A, I'm sorry, I keep putting an E on there and I don't mean to, because when we write it, we just write the first three letters. When I'm trying to find the sine of my angle, angle A, then it would be whatever the measure of BC is over the measure of AB. All right? Once again, this is all in reference to angle A. So sine of my angle, whatever angle I'm dealing with, is going to be the opposite over hypotenuse. All right, let's look at the cosine. All right, so if I want to find the cosine of my angle, we write it cosine COS of my angle. My cosine is my adjacent over the hypotenuse. All right, so if I were dealing with angle A, then the cosine of my angle would be AC over AB. All right. All right, then we have what we call tangent. All right. So we want to look at the tangent of our angle. So there's sine, there's cosine. Let's talk about the tangent of our angle. All right, the tangent of our angle would be the opposite over adjacent. So in reference to angle A, the tangent of our angle would be BC over AC. All right? And so we would be able to use whatever measures we have to find the cosine, or the sine, the cosine, and the tangent of those angles. All right? There are still 3 possible combinations of quotients on the side lengths that we briefly introduce here. All right? So here, the value of the sine is the value of the ratio of the length of the opposite side to the length of the hypotenuse. Cosine is adjacent over the hypotenuse, and tangent is the opposite of adjacent. All right? Now we're going to look at possible combinations of the side lengths. All right? So now we have, and I realize this seems like a lot, but now we have what we call the secant of our angle. All right? The secant of the angle is the value of the ratio of the length of the hypotenuse to the leg of the adjacent side. So I would write it like this. The secant of my angle is the hypotenuse over the adjacent. All right? Give me just 1 second, guys. I got something popping up here. All right? So here's my secant. All right? We also have what we call our cosecant. The cosecant of our angle. All right? So we would write it like this. CSC of our angle. To find the cosecant, I would do the hypotenuse over the opposite. Notice with sine, cosine, and tangent, our hypotenuse was on the bottom. In our secant and cosecant, the hypotenuse is on the top. And we'll talk just a little bit. We'll kind of compare these. All right, then we have what we call our cotangent. All right, the cotangent of our angle would be written like this. COT, and that is the adjacent over the opposite. All right? Now, we're not going to use secant, cosecant, and cotangent a whole lot because given any 2 sides, it's possible to write the quotient so as to get the sine, cosine, and tangent. All right? But I wanted to introduce secant, cosecant, and cotangent to you. All right, so with that being said, let's take these things and set them aside, and we're going to revisit them here in just a few minutes. All right, so in example number 4, or exercise number 4, in triangle PQR, the measure of angle P is 53 2/10 degrees, and the measure of angle Q is 36 8/10 degrees. Compare the following tables. All right, so we have the measure of our angles, and they want to know what are the sine, cosine, and tangents of these. All right, so we're going to look at the sine of our 53 2/10. So our opposite, so I'm looking at this angle here. The opposite is 4. And the hypotenuse of my triangle is 5. So the sine of this would be 4/5. All right, let's look at cosine. So we're going to look at the cosine of 53 2/10. The adjacent is 3 over the hypotenuse, which is 5. All right, let's look at the tangent of this. So I'm going to look at tangent of 53 2/10. And that is our opposite, which is 4, over the adjacent, which is 3. And I can leave it this way. All right, I'm going to look at the sine of 36 8/10. So now remember, we're switching angles. So now I'm going to look at the opposite of that, which is 3 over the hypotenuse, which is 5. All right, the cosine of 36 8/10. So cosine is adjacent. That would be 4. And hypotenuse would be 5. And then our tangent of 36 8/10. All right, our tangent is opposite, which is 3, over our adjacent, which is 4. All right. Not extremely difficult. The main thing is making sure you remember. You remember those, what sine, cosine, and tangent mean. In the triangle below, the measure of angle A is 33 7/10. The measure of angle B is 56 3/10. Complete the following table. They want us to find the sine, cosine, and tangent of these. All right. So we're looking at the sine of 33 7/10. Now, they did not put this here for us. All right, so I want to introduce you to something. I want to introduce you to something that I did not know until actually I started teaching, SOHCAHTOA. If you can remember the term SOHCAHTOA, this will help you to remember, because this means sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. So if you can remember SOHCAHTOA, then you can remember sine, cosine, and tangent. All right? So sine is the opposite, so we're looking at 33 7/10. So the opposite of that is 2, all right, over the hypotenuse, which is the square root of 13. Now normally we wouldn't leave it this way, but they didn't tell us to simplify it, so we're going to leave it 2 over the square root of 13. All right? The cosine of 33 7/10. So cosine is the adjacent, which is 3 over hypotenuse. So 3 over the square root of 13, not 3. All right? And then tangent of 33 7/10 is the opposite, so 2 over the adjacent, which is 3. All right? Let's look at sine of our new angle, 56 3/10. Sine is the opposite, so 3 over hypotenuse, square root of 13. All right? Cosine of 56 3/10. Cosine is the adjacent, which is 2, over the hypotenuse, which is the square root of 13. And then tangent of 56 3/10. Tangent is the opposite, which is 3, over adjacent, which is 2. All right?
Teachers, pardon the interruption. Mr. Massey and Miss Holly, please go to the board office. Mr. Massey, Miss Holly, please go to the board office. Thank you.
In the triangle below, let E be the measure of angle E, and let D be the measure of angle D. Complete the following table. So now they're not giving us measurements, they're just naming the angles. Alright, so now we're going to look at the sine of D. Alright. Sine, let's see, find our angle D. Sine is opposite, so that would be 4 over the hypotenuse, which is 7. Alright. Cosine of D. So cosine is adjacent. That would be the square root of 33 over my hypotenuse, which is 7. Alright, tangent of D. Alright, tangent is the opposite, which is 4 over the adjacent, square root of 33. Alright, now we're going to do the sine of E. Alright, so find E. Sine is opposite, so the square root of 33 over my hypotenuse, which is 7. Cosine of E. Cosine is adjacent, which is 4 over my hypotenuse, which is 7. And then tangent of E. So tangent is opposite, so square root of 33 over the adjacent, which is 4. Alright, hopefully you're not finding this too difficult so far. Right now we're just getting into how do we find the sine, cosine, and tangent. Alright? In the triangle below, let x be the measure of angle x and let y be the measure of angle y. Complete the following table. Alright, so the sine of x. Alright, the sine of x is opposite. And if you want to write this down, oh, nope. Alright, so sine is the opposite of x, which is 1, over the hypotenuse, which is the square root of 10. Alright, cosine of x equals, cosine is adjacent, so that would be 3 over hypotenuse, the square root of 10. And then tangent of x. Tangent of x is the opposite over the adjacent, so 1/3. Alright, and then the sine of y. So we're switching angles here. So we're looking at the opposite, which is 3 over the hypotenuse, which is square root of 10. Cosine of y is the adjacent, over the square root of 10, so 1 over square root of 10. And then the tangent of y is equal to the opposite, which is 3 over the adjacent, which is 1. And you can leave it 3 over 1 or you can write 3, but normally you're going to see it left as 3 over 1 right now. Alright, Tamara did not finish completing the table below for the diagram similar to the previous problems that the teacher had on the board, where P was the measure of angle P and Q was the measure of angle Q. Use any patterns you notice from exercises 1 through 4 to complete the table for Tamara. Alright, so, well, what did we figure out about the sines and cosines of our angles? Well, the sine of x is the same as the cosine of y. So in that case, I know that the cosine of q would be 11 over the square root of 157. We figured out that the cosine of x was the same as the sine of y. So I now know that the sine of q is 6 over the square root of 157. Alright, and then what did we figure out about the tangent? Guys, tangent is the top number of the sine over the the top number of sine over the top number of cosine. Alright, so the tangent of q would be 6 over 11. Or if you didn't notice, they're opposites here. Alright? They're opposites. Hopefully this is recording because I keep getting something popping up on the screen. So if it blocked out, I'm sorry. Just pause it and write your information down. Explain how you were able to determine the sine, cosine, and tangent of angle Q in exercise 7. So we're just going to write what we said. Alright? So the sine of Q was the same as the cosine of P. The cosine of Q was the same as the sine of P. And then the tangent of Q was the opposite of the tangent of P. Alright? So the tangent of P was 11 over 6. So the tangent of Q was 6 over 11. Alright? Alright, so the sine, cosine, and tangent of an angle can be used to find unknown lengths of other triangles using within figure ratios of similar triangles. Alright, so if if 0 is less than the angle measure, which is less than 90 degrees, we can define sine, cosine, and tangent of that angle. Alright? So if the angle is somewhere between 0 and 90, then we can define the sine, cosine, and tangent of that angle. Alright? Take a right angle that has an acute angle with angle degree measures and use the appropriate side lengths. If we use different right triangles, why will we get the same value for sine of the angle, cosine, and tangent of the angle? So let's kind of look at this. Let's look at these two angles. And I'm not going to draw these out. I just want to kind of look at these. So I'm going to zoom into these really closely. And I want you to look at this. Alright? The triangles below contain approximations for all lengths. If the Pythagorean theorem is used to verify that the triangles are right triangles, then you will notice that the values are slightly off. For example, the length of the hypotenuse contains 11 decimal digits, not the 5 shown. So find the sine of A, the cosine of A, and the tangent of A. Compare those ratios to the sine of D, cosine of D, and tangent of D. What do you notice? Alright, well, we're not going to spend a whole lot of time doing this, but what I want you to see is you should notice that the sine of A, or the sine of A, is equal to the sine of D, the cosine of A is equal to the cosine of D, and that the tangent of A is equal to the tangent of D, because they are similar triangles. Alright? They are similar triangles. Alright, so guys, that is our lesson for the day. Not an extremely hard lesson. Introducing you to sine, cosine, tangent. So now we can start talking about that vocabulary. Hope you have a great week, have a great spring break, and I will talk to you guys later.